Hello Diploma 8 students, and welcome to the third video on this series on internal assessment in chemistry. And in this video we're going to be talking about the structure of a good internal assessment. How should you organize an internal assessment in chemistry to maximize the marks that you get? The first thing that we have to think about is that an internal assessment is a scientific argument, and therefore it has to follow somehow the scientific method. You start with a research question. You are going to do some research and get some background information about the topic for you to be able to formulate a hypothesis that is justified with the information. Then you're going to design a methodology. You're going to collect data. You're going to process the data. You're going to represent the data. You're going to analyze it. Then you're going to use the analysis to write down a conclusion. And finally, you're going to do an evaluation where you identify limitations and suggest improvements for the investigation. The internal assessment has to reflect this order, and every section should contribute to answering the research question. They are all interconnected. So the first thing we're going to be talking about is the research question. We already discussed the need of the topic to be related to chemistry, but how can I formulate a research question that is strong? How can the research question be focused and chemically meaningful for the internal assessment? All right. So typically, students, when they formulate a research question, they formulate weak research questions because the question is too vague or broad, so it cannot be investigated within the scope of an internal assessment, or the variables that are to be investigated are not clear in the research question, or maybe the question is difficult to measure. And in other instances, you have a research question, and when you look at the methodology does not really address the research question. So a strong research question in chemistry should have clearly identified variables. And yes, the two variables that we need to have in the research question are the independent variable, which is what you are changing, and the dependent variable, which is what you are measuring. Because in a chemistry investigation, you should always be measuring something and changing something. The rest of the things have to be controlled, have to be constant. Now, the question needs to be focused and specific. It needs to be measurable experimentally, and it has to be meaningful from a chemistry point of view. So this is the foundation of the whole internal assessment. A weak research question normally will be vague, broad, difficult to investigate. A solid research question will be clear, will be precise, will identify the variables, and will identify exactly what's being measured. For example, how do acids react with metals? Well, this is related to chemistry. It's just very broad and is not specific enough. It would be much better to have a research question that actually talks about the variables that you are going to be changing and measuring. So a strong research question for the same investigation would be something like, how does hydrochloric acid concentration, that's your independent variable, affects the volume of hydrogen gas produced, that's your dependent variable, when reacting with magnesium ribbon? Okay, this is a much more specific research question because you are mentioning the acid, you're mentioning what you're changing, your independent variable, and you're mentioning the volume of hydrogen gas, which is what you're measuring, your dependent variable. Another one. How do catalysts affect reactions? It's very vague, very broad. You have thousands of catalysts, you have thousands of reactions. Which one are you talking about? You could say, how does the concentration of manganese 4 oxide catalyst affect the rate of hydrogen peroxide decomposition measured by oxygen gas production? This tells you what is the independent variable, tells you what is the dependent variable, tells you how it's going to be measured. So in summary, a good research question should make the entire investigation obvious. Now, the next thing you have to have in your investigation is background information. The background information is the chemistry that directly supports the investigation. And the typical mistakes that students make when they are writing down the background information is that they're just copying down textbook content. Sometimes they even quote it. When what you have to do is really explain with your own words the science behind your investigation. Sometimes the theory is excessive, is very descriptive, and is not really connected to the variables. So a strong background information, what it does is it tells me what is the relevant chemistry to that research question, is linked to the variables that you are changing and measuring, and is going to support the formulation of the hypothesis, which is logically the next step. It needs to explain the expected trends that you are going to find, and is going to introduce chemistry concepts that are relevant to this particular investigation. A typical mistake that students make here in the background information is to include large amounts of chemistry theory that never becomes relevant during the investigation. So the background information has to be very specific for what you're studying. And after you finish with your background information, what you need to have is a hypothesis. And this is a very typical mistake that students do when they write down the hypothesis. A hypothesis is just not a prediction. Yes, it does have a prediction, but the prediction needs to be justified. Reason why the hypothesis normally appears after the background information, because in the background information, you are getting information about how is this happening, what is the science behind, and then you use that information to justify the prediction, what you think is going to happen in your particular experiment. So a weak hypothesis will not be supported by science. It will be a vague expectation, doesn't have a chemistry explanation, and is sometimes disconnected from the theory. A strong hypothesis is based on the chemistry theory that you have laid out in the background information, explains the expected relationships between the dependent and the independent variable, is linked to the variables, and is scientifically justified. So not only you are telling me what you think is going to happen, but you are explaining scientifically why you are making that prediction. And here we are going to stop for a second just to reflect about one fact, which is that not all chemistry internal assessments need to be experimental, especially from COVID, where students didn't have access to chemistry labs. The IB kind of gave you a little bit of more room for investigations that are based on different types of data. Sometimes the data is coming from simulations, sometimes it's coming from databases, or sometimes it's coming from modeling. So these investigations are also appropriate. There are non-experimental investigations. And we're going to extensively talk about these investigations in another video. But in this video, we're going to focus on experimental investigations, where you have laboratory measurements that you're making, you're controlling the variables, you have practical procedures, and you have direct data collection. Now, after you have your hypothesis, the next logical step is to lay out a methodology. The methodology has to be very clear and replicable. This means that if another scientist reads your procedure, it has to be able to replicate your experiment really, really precisely. So a weak methodology is not clear, it's missing the control of the variables, it has insufficient detail, it doesn't account for the uncertainties that you always have because you're using apparatus and the apparatus have a precision. And sometimes, for example, you don't account for repeats and things like that. A strong methodology clearly defines the variables. You clearly tell me what is your independent variable, what is the range, how are you deciding the increments, what are the units and what are the uncertainties. And you do exactly the same thing for the dependent variable. What measuring units are you using? What apparatus are you using? What is the precision of that apparatus and what are the uncertainties of this measurement? You have a procedure that is very detailed, normally a step-by-step set of instructions that tells me exactly the different steps that you're following in your procedure. You're controlling the conditions, you're identifying all those variables that can affect the experiment, but that you have to control. You are talking about the appropriate number of repeats, you're talking about the uncertainties, and you're talking about the safety. You have to have a full risk assessment of your procedure as well. Now, after you do the method and you write down the methodology, you are going to get some data because you're going to do the experiment and you're going to get raw data. You're going to process this raw data in different ways to get processed data, and then you're going to use the processed data for an analysis. So the data is the most valuable asset that you have in your investigation. If you have good data, the analysis is likely to be good. So when you get the data and you process the data, an analysis that is weak probably will just consider the raw data. You will have calculations that are just repeated. You will have comments that are descriptive. You will not identify trends, and you will not identify the chemistry that is associated to your data. Whereas a strong analysis will process the data meaningfully and clearly, will identify and explain the trends that you observe in the data, probably using a graph. You will identify the relationships that you observe in the data, and you will explain those relationships. It will have a link to the chemistry theory that you've been talking about in your background information, and it will lead to a conclusion that is supported by the evidence that you do have. So saying things, for example, like the graph increases as concentration increase is not specific enough. You should be saying things like increasing the concentration increases the collision frequency, and this produces a faster rate of reaction. The analysis is just not presenting the calculations and the graphs. A strong analysis explains scientifically what's happening in those graphs. So a graph without an interpretation, it has limited scientific value, to be honest. All right, so try to be meaningful in your analysis and identify trends, talk about anomalies, uncertainties, proportional relationships like correlations and things like that. And finally, the last part of your investigation is going to be your conclusion and your evaluation. Strong conclusions and evaluations are supported by the data that you collected. And the typical mistakes that you see in a weak conclusion and evaluation is that you have unsupported claims, you have exaggerated certainty, you have generic limitations, and unrealistic improvements. So, for example, saying things like human error, that's not specific enough. In a strong conclusion and evaluation, you will have the conclusion that answers specifically the research question based on the data that you have in the experiment. You have to acknowledge the uncertainties that you have because you're using apparatus that have a precision. You have to evaluate the reliability of the data that you're getting. And you have to, on top of identify the limitations, you have to explain how your limitations affect the reliability of your data and suggest realistic improvements for these limitations. So the evaluation has to be scientifically justified. Basically, many students think that the evaluation is just a list of errors that you have made when you're doing your experiment. And the conclusion sometimes is not based on the data that you have. You need to realize that conclusions should be based specifically on the data that you're obtaining from the investigation after the processing. And yes, you can link it with scientific literature if you want. That actually gives strength to your conclusion, but it has to be based on your data. Examiners are looking for scientific judgment in your investigation, not just for your opinion. And strong conclusions are directly linked to the data that you are getting in your investigation. Remember that, because this is very important. Finally, you need to be careful with the communication and the structure of your internal assessment. You need to realize that examiners are human beings, and it's difficult for them to reward you with marks in the different criteria if they don't understand or they don't see the structure of the essay. So you need to have a logical section organization with titles for the different sections. You need to have clear tables and clear graphs, properly labeled, with axis labeled, with a title, with units, with uncertainties. You need to have concise scientific writing. You need to label data properly so they understand what the data represents, and the analysis have to be easy to follow. An examiner should be able to understand and mark your investigation reading it only once. If the examiner has to stop and wonder what you mean, probably your communication is not that clear, and that will be penalized in communication. Okay, and this is all for this video. In the next video, we're going to be talking about the assessment criteria. I'll see you there in Diploma Edge.